right, we're ready for parent function 11, which is the sine function. Y equals the sine of x. You should remember this from Algebra 2 and from FST. So if you haven't already, go ahead and pause the video. Try to graph it yourself. Okay? But Mr. Leckie's listing some anchor points for us. And these come straight from the unit circle. So you remember on the unit circle, the first angle on the unit circle is 0. I'll spit it out. First angle is 0, and the y-coordinate of that dot when you're over there on the left side is also 0, and then you move up to 90, and you move around like that. So, of course, when you make your picture of the sine curve, you're going to go over your period to 2 pi, chop it in half to pi, and then you get your dots. Okay? So you need to have 5 key points. We forget to write that on the notes, but 5 key points for your parent
we're gonna
sine
spend
function.
almost half of second semester
Probably 2/3 ad nauseum.
with sine, cosine, tangent, and all these other functions.
We love
so.
Trey. Now remember that we're only graphing one period for right now, but it does continue in that direction, and that's going to help us with some of our attributes here. So the domain is really from negative infinity to infinity, or all real numbers. The range is going to be from -1 to +1, including both. The symmetry, since it goes through the origin and you could rotate it, is odd. It is bounded, meaning above and below. You could just write bounded. There are no asymptotes. There are no discontinuities. But increasing and decreasing gets a little tricky, and so we're going to restrict to just one period. When we look at just the blue period that Mr. Leckie has drawn, we start off going up from 0 to pi over 2. So we would be increasing from 0 to pi over 2. And then we start going down for a little while, but at 3 pi over 2, we go up again to 2 pi. Now, of course, the function doesn't actually stop at 2 pi, but that's why we wrote down for one period. It decreases in the middle from pi over 2 to 3 pi over 2. Okay, extrema. Well, we have an absolute max. We have a highest of a high point, and that's at 1. We also have an absolute minimum, and that's going to be at -1. Remember that we are only looking at y-coordinates, so it doesn't matter what the x-coordinate is associated with that. So end behavior. As we look at this graph, end behavior says go to the left and go to the right. And when we go to the left on sine of x, it just keeps going up and down, bouncing. And when we go to the right, it doesn't really bounce like this. It does this.
Well, it oscillates.
It oscillates, which means there is no end behavior.
It doesn't go up. It doesn't go down forever.
There's nothing we can describe
settle
there.
on a number. Just
So it does not exist.
we say both of them do not exist.
Alrighty, that'll do it for sine function.
That'll do it for number 11.